This instructional video is designed to show you how to apply the concept of molar mass in the context of an ideal gas law problem. And so here we have two different situations. We'll work on the first one and then the second. So here we have 0.52 grams of a gas occupying 610 milliliters at 0.507 atmospheres and 45 degrees Celsius. The question is to find the molar mass. So we can begin by recognizing that we need to use the ideal gas law. PV equals nRT. And we have a volume, temperature, and pressure. So we want to solve for number of moles. And that is PV over RT. By plugging in these values, we'll be able to determine the number of moles in 0.52 grams. So the pressure is 0.507 atmospheres. Our volume is given in milliliters, but we need liters, so this is 0.610 liters. We have our gas constant, 0.08206 liter atmosphere per mole Kelvin. Because the temperature is given in degrees Celsius, but our gas constant uses temperature units as Kelvin, we have to convert that, and we get 318.15 Kelvin. So we can use our calculator to step through and get a value for the number of moles present, and we have 0.0118 moles of gas present. Now, because we know that we need to determine a molar mass, those 0.52 grams represent 0.0118 moles. And once we simplify by dividing through, we find a molar mass of 44.07 grams per mole. So that concludes our first version of a molar mass problem. Our second one has a setup with an ideal gas given a molar mass of 95.0 grams in 1 mole. And we want to know what volume will 5 grams occupy at 25 degrees Celsius and 1.02 atmospheres. So in order to do this, we would use the ideal gas law, solving for the volume, since that's what we're asked for. And in this case, what we have is temperature and pressure given to us, but we need the number of moles. And so in order to do that, we recognize that if it is 95 grams per mole, then those 5 grams will need to be divided by our 95 grams per mole. And this gives us a value for our number of moles as 0.053 moles. And so now we can take this value for N and plug it into the ideal gas law. So our volume, 0.053 moles, times our gas constant, 0.8206 liter atmosphere per mole Kelvin. Now we're given 25 degrees Celsius. We need that in degrees Kelvin. So that is 298.15 Kelvin. This is all divided by the pressure, which is 1.02 atmospheres. So we can multiply through, divide by our 1.02 atmospheres, cancel out our units, verifying that we do in fact get a volume in liters. And you should determine that this is 1.27 liters. So this shows how we can take advantage of what we know about molar masses and apply that to an ideal gas law problem.